What is up, everyone? I hope you guys are having a great day. In this video, I just want to kind of admire some of the work that I did back in college. So I do have a research paper that I got published with my name on it. Now, granted, I was like a sub-publisher. These are the people who did the heavy lifting. They were the professors and the PhD students who actually knew what they were doing. And I was like the lost research assistant who tried to understand what was going on, but I really had no clue. But I think I was able to contribute to it. So I just want to kind of share this with you all. I've tried reading through this paper, and a lot of the stuff is like kind of way over my head, and there's some things that I've seen here which is actually like something I actually worked on during the summer internship where, you know, like the FourYear Transform stuff I did, but it was just a great experience. And I look back now and I'm like, man, I'm really glad that I had the opportunity to do some actual legit research for my college when I was in school. So to give you a little overview, basically, I think it was back in 2012, yeah, there was an REU, which I think is a research experience for undergraduates, where a bunch of different students, I think it was like 20 or something, come into the computer lab every day for 8 hours, 5 days a week. And we basically just learned about computer vision. That was actually like, it was in the computer vision lab. But we learned about computer vision. We took like a 2-week crash course of all the different topics in computer vision. And then we were actually paired up with one of the PhD students to try to research a particular topic in computer vision. So after the first 2 weeks, I decided to pick a project that was related to counting crowds. So the problem that we have here is, given a image of a lot of people in a crowd, and the computer correctly estimate how many people are there, right? So if you look at this is a hard problem, right? It's hard to get a really close estimate of how many people are like down the street. It looks like there might be thousands and thousands and thousands of people here. And the question is can you get a computer to efficiently give you close estimates? And that is basically what I spent my entire summer doing one time. So I'm going to kind of walk through some of these slides. Basically, every week we had to make slides and present them to our supervisor. This is like the main professor in charge of everything. And along the way, we talked with our PhD student who we were kind of paired up with. Well, I guess he wasn't a PhD student. He has a doctor in front of his name. So sorry for sorry for not acknowledging that. He's not a PhD student. He's someone who's under the main professor guy, okay? And this guy as well. So yeah, I picked my project, and the first 2 weeks we kind of were taught a bunch of topics, and we had to come back and present it to the group of students. So we learned a lot. I read through something about image processing, where we learned about like how to do image transformations, how to do binary thresholding and stuff like that. We learned about optical flow. We had to implement something in MATLAB using optical flow, Lucas Canad, I guess. And this piece of technology basically just tells you, given a video or 2 images, what is moving on the images. So in this case, this car moves, so it turns green. Or in this case, the tree is moving from the wind, so you can see that it's highlighting the areas where stuff is happening, where movement is happening. And I guess this is really useful for doing like object tracking, so you know like what's moving in the scene and kind of have the computer focus in on those sub-pixels, I guess. And then we learned something about Sift. This is just a way to basically take an image and find key points inside the image so that you can compare it to other images and know if you're looking at the same image. So for example, as an example, let's say you take a picture of the Eiffel Tower, right? Well, what you do is you take a bunch of Sift descriptors out of that, or key points, you save them to your database. So then later on, if someone takes a picture of the same Eiffel Tower, but maybe a different angle, or it's a little bit darker outside, it can still search your database of descriptors and tell you if that picture is the Eiffel Tower or if it's somewhere else. And I think this is probably done with like a Google reverse image search, very similar. Another thing we learned was canny edge detection. So that's just basically taking an image and filtering out all the colors and all the actual like, it's basically a way to find the edges of a picture, okay? So you can see that over here, this is the tower, and all the edges are pretty much threshold of value of 1, and then the dark areas are a binary threshold of 0. Same with pennies and Gabe Newell. And this is good for just doing like I don't really know what this is good for. I guess it's good for like object detection, try to like crop out certain areas. Like if you wanted to segment all these different pennies or quarters, so you could do like the edge detection and then do some type of like morphographic, I think it's called morphological, something morphological computer vision. Morphological image processing. Yeah, I think it's called this, morphological image processing. I don't know. I knew it at some point. I don't know anymore. And then we kind of met with some of the PhD students and their supervisors, and we tried to figure out projects that we might be interested in. So that is where I saw the crowd counting and I thought, hey, that might be pretty cool. Now, I'm not going to go through all this, but week after week, you basically just build upon your knowledge. Like the first week, you try to look at an image and think to yourself, okay, what algorithm can I build to count all the heads here? Right? So the first thing you start with is like template matching. If I have a small template of a person's head, and I run that over the image and get a close estimate. So yeah, you have the image. Here's a template of someone's head. You run it over, and that's how many heads that you found in the image. So, and then you run into issues where like, okay, well, if you notice on this image, people get smaller as the camera is further back. Like further back in the image, the perspective is going to mess up people. So if you do a perspective transform, you can get closer estimates. So you notice that the template matching is actually working better here. So we learned that. So that's what I did week 3 to 4. I just kind of kept trying new things, learning new things. And then finally at week 5, like you learn something new and try that. I don't know what this one is actually doing. Oh, this was trying to do like a heat map. So basically using like a sliding window of some type of like Sift descriptors or something. You can basically see like the lighter spots where people's heads might be. And then using that information, you can kind of graph a bar chart to know, like, I guess the average here is how many people there might be, if that makes sense. I think this image has around like 300 and something, but this approach got like 275. So you just keep on trying new things to figure out how to count the crowd. And then week 6 to 7, I started learning about something called FourYear Transform. And, most of these topics, the research assistant or the PhD student will tell you like, hey, maybe look into this topic. Spend the week learning about FourYear Transform and how you can do a 2D FourYear Transform on an image to get close estimates. So here's an example of how it works. If you have like a 2D grid of squares, 484 squares, you can do a FourYear Transform over that, and this image will have a bunch of peaks of numbers. And then you can basically take the height between the center and this peak and the width between this and that, times it together, and you end up getting 484 squares. So it's a pretty cool technology, but then you try to do it with things that aren't necessarily like a grid. So you try with this, you find out that there's 258 objects in that. You try FourYear Transform, it looks like this. You still do the same logic where you find peaks. And what happens is you get a really close estimate. 17 by 15 gives you that many objects. So then you're like, okay, well, can I apply this to people? I have an image of a bunch of soldiers standing here in a very uniform pattern. You do FourYear Transform on it. You times it out. You get a really close estimate of how many people are in the picture. Same thing with this. This is another image where the FourYear Transform actually seems to help. Like you get really close estimates doing this. But you find out that there's other pictures like this where, the FourYear Transform, it doesn't work that well because the scaling and stuff like that. Like people are bigger up here, they're smaller back there. So then you spend more time just trying new things. Week 8, you start doing like head detection, right? So I basically, similar to the other stuff I did, you slide a template of a head, you get a heat map of where heads might be, you count those up, you get those estimates. And then I started doing something strange with like FourYear Transforms and trying to create these maps of densities. So you can basically figure out where in the image are there more people. So the red means it's more dense, blue means it's less dense. And you can apply that to different images to maybe change your results of your head detection, right? So if your head detector is saying there's 100 heads here, then you know that it's probably wrong, right? Versus if it says there's 100 heads here, you might be like, okay, that's probably legit. Week 9, let's see what I learned here. So again, I'm just like combining these different methods to see if I can improve my results. So head detection mixed with the FourYear stuff. I ended up getting really close estimates with that picture. Again, over here, really close estimates with that picture. This one also gave close estimates, I think. What else is there? Yeah, so I think that approach worked the best. Did I do week 9 already? Was that week 9? Yeah, it was week 9. And then the final 2 weeks, again, I'm just trying different things. Like you just do the edge detection, see if that improves your results or if it does worse for your results. And then the 12 weeks ended, right? So through all of this, right, this research, I learned a lot of things about computer vision, and you learn about just every day you try something new. You see if it works. If not, you then move on to something else. See if it works. If it improves your results, great. If not, then you move on to something else again. And at the end of all this, we got to present our findings with we had this little conference room we rented out. All the students were there with their own posters. and we basically just had to explain our pattern to other people. And at this point, I don't know if any of this stuff actually worked, but it was fun. And then also at the end of this, we got to go to one of the companies that was nearby and basically present our project there. And I actually got hired at this company through, I think doing this research thing actually got me hired at this company. So right out of college, I had an offer from this company, and yeah, I didn't have to worry about where to find a job. Could I have worked at other places? I'm sure I could have, but for whatever reason, I wanted to stay in my city or stayed near my city. So I should have probably found jobs that paid more because this place was not paying that well. But I mean, it all worked out. And then later down the road, like this is like a year or two later, or a year later or something, they messaged me or they emailed me and they're like, hey, we have a research paper we're about to publish. Would you like your name on it? I said, hell yeah, I do. So they put my name on it, and now I have a legit research paper with my name on it. Now again, the approaches they took here, I don't understand half the stuff they're doing. And I didn't actually participate in doing this stuff. Like here, they split up the image into a grid, and then for each grid, they use the FourYear technique to figure out the density. So I think I'm kind of responsible for that part of the research. Same thing here. They get an image, they break it down into smaller groups, and then they try to figure out the densities and stuff like that. But yeah, I'm just really proud of this work. Although I didn't write this research paper, I feel like I did help contribute to the research that was done here. And for anyone who's in college right now, who's doing a computer science degree or engineering or whatever, I highly recommend that you try your hardest to get some type of research internship, right? Find some program where you can become a research assistant, maybe through like a stipend where you can do full-time research over the summer, because this experience was super invaluable. Like I learned so much and it was so much fun. I met a lot of people who were just, you know, trying to learn computer science like me. And I thought I didn't really know what I was about to get myself into. I thought I was like super inexperienced. But then when I got there, it's like it turns out that everyone doesn't know what they're doing. We're all just trying to figure out how to get something going. And luckily for me, you know, we ended up getting a research paper published from this, and that's something that I can put in my resume. But yeah, I do look back and I'm like, dude, this stuff was so fun to work on. Like if I could just be paid the amount I'm being paid now to just sit there and research on these different things and try to figure out how to solve these problems that are like really interesting, I'll be super happy. Not that I'm saying that it's not fun building websites, but if you compare building a website to designing an algorithm that can analyze a picture and tell you how many people are in a crowd, I'd probably pick the second option because it's just a lot more interesting. Or how to do like face detection, or how to do motion tracking, or how to do some type of, I don't know what I'm getting at, but I hope you understand. I could do another talk about college and research and why I didn't go in to get my PhD or my master's, although I feel like I probably would have thrived in a research environment, but sometimes the money speaks louder than the college is willing to pay. All right, I hope this was informational. Hope you guys have a little bit of insight of like what a research opportunity is at a college and the cool stuff that you could be doing and researching on and just having some fun, you know? This is why we love programming, right? We get to solve really interesting problems, and the harder the problem is, the more fun that we usually end up having. All right, so if you like this video, be sure to leave a comment below, because I'm also interested in hearing if you guys have done any type of research like this, or if I'm just the only person alone in my island of research. And then secondly, give me a like, because it really helps my channel grow. And then lastly, if you're new to this channel and you've just made it this far, click that subscribe button, because I'm going to be posting some random videos like this in the future that you can hopefully learn a little bit from. All right, thank you so much for watching, and happy coding.